So hello, everybody, and welcome to another episode of the EnVisioneering Exchange podcast. I'm John Sheff, Director of Public and Industry Affairs at Danfoss, and I'm joined here by Vic Marinich, our Global Marketing Director for AC. In previous episodes, we've discussed the overall state of refrigerants in North America and talked a little bit about A2Ls, the flammable refrigerants that we're moving into. Today, we're going to take a deeper dive into the air conditioning segment, and we have Vic here to discuss it. So, Vic, why don't you introduce yourself and give a little bit about your background before we get started?
Sure, John, thanks. So, again, my name is Victor Marinich. I've been here with Danfoss now for just about 20 years, and I've been in the general HVAC industry for now pushing 30 years. Today, in my role as the director of our air conditioning segment, I'm responsible for setting our strategy globally on components, heat exchangers, electronics, and controllers. And so, yeah, here in North America especially, we've got some very exciting times coming with a lot of the refrigerant changes that we're going to talk about.
Definitely. So let's jump in and maybe describe what the current landscape for air conditioning refrigerants in North America is right now.
So in North America, you know, as one of the old guard guys, you know, we grew up with R22 and kind of R22 was everywhere. And then back in 2010, we had all equipment being banned for use with R22. And that was because R22 is an ozone depleting chemical. And we found it was destroying the ozone. And I think everybody remembers those days. And we got away from R22 and moved on to what we're currently using, which is R410A. And so, for the most part, large or residential units up to larger systems with scroll compressors, we're using R410A, and then larger chillers, screw compressors, centrifugal compressors, we're using R134A. 2020 will be a landmark year here in North America when it comes to R22, because by the end of 2019, we're going to not be allowed to produce any more R22. And so that means all service and everything else done with R22 units will have to be done with existing refrigerant or with reclaimed R22 refrigerant.
But that doesn't mean that R22 is completely out of the picture, right?
Yeah, of course not. I know there's a lot of panic that suddenly the unit that you've got at your house is going to be impossible to service because R22 is gone. There is plenty of stock of R22. There's lots of reclaimed R22. And so at least for the foreseeable next few years, if your unit could be serviced today, if it made sense to service your R22 unit today, it'll make sense to service your R22 unit in 2020.
And R22 units are still relatively recent installations there, right?
Well, they're probably coming close to their end of life. They're at the newest are already 10 years old. And besides just the refrigerant, right, we also have to consider, of course, the system efficiency. And we know efficiencies have gone from back in 2010 around 10 SEER. Now we're looking at 13 and 14 SEER. So it's really more than just the refrigerant change you've got to consider when you're going to look at changing out a unit.
Okay. So let's kind of move forward into what's going on now in the current refrigerant phase down that's happening in a patchwork across the United States. Let's take a quick review and talk about SNAP 21, which affects air conditioning, and where we are with that.
Sure. So everybody was happy to get rid of our ozone depleting chemicals, the CFCs like R22, but we moved to HFCs like R410A, and what we've learned over time is that while they are not ozone depleting, they have an impact on global warming. They have a very high global warming potential, and anybody that listens to the news understands the severity that we've got now with global warming. So we need to move out of these HFCs and into something else that has a lower global warming potential. The challenge, of course, is what we move into. There's lots of alternatives, but they have either flammability risks or they could have some different thermodynamic properties. So it's not a simple change like it was, relatively speaking, from R22 to R410A.
But SNAP 21, which was the federal program in the previous administration, only covers chillers, correct?
That's right. The SNAP 21 rule, which was put in place by the EPA and since found to be unconstitutional, it was trying to control the level of global warming potential, keeping it below 750. And they did that by looking at SNAP stands for Significant New Alternatives Program, meaning what alternative refrigerants are out there that they can work with. And so they we're banning 410A, banning R134A, and looking to go to some of these new alternatives. We may start hearing names like R32, R454B, R452B, R1234ZE, and so on.
But this was just for chillers. And so there are a handful of states in the, quote, U.S. Climate Alliance, a group of governors who have pledged to uphold their commitment to the Paris Climate Accord, who are implementing SNAP 20 and SNAP 21 for chillers. And so the industry was anticipating this and is in relatively good shape to implement. It's California, though, that's kind of the sticking point and the outlier.
That's right. Because the alternatives that are being used today or being recommended today are all what we call A2L refrigerants. A is the ASHRAE designation for a less toxic refrigerant, and that's most of the refrigerants we deal with today, 410A, R134A, and so on. And the 2L means a mildly flammable refrigerant. Today, most refrigerants are a 1 meaning non-flammable. So we're moving now away from a non-flammable, low toxicity refrigerant to a low toxicity but mildly flammable refrigerant. And I think everybody has always has the question, what's mildly flammable mean, right? And the difference we can consider highly flammable are things like propane and isobutane, and those, when there's an ignition source, those will explode, right? I mean, I think we all know what happens when you catch propane on fire. These refrigerants will burn and not create an explosion. So there is a significant difference around safety, and of course that's important on air conditioners that are going to be in residential and commercial buildings.
And right, so that's kind of the main sticking point. In chillers, where we can put the unit in a machine room, it can be isolated, we can have sensors. We have standards to deal with that in place that have been well accepted. It's really in California where they are looking to implement a 750 GWP limit for residential and light commercial, where we have some safety issues using even mildly flammable refrigerants.
That's right. Chillers typically are big centralized systems, and they're either an air-cooled unit, means it's sitting outside, so your entire refrigerant charge is also outside. So in the event of a leak, even if it's a mildly flammable refrigerant, it's going to leak to the atmosphere. And that, while of course nobody wants to have a refrigerant leak, their safety concerns are minimized. If it's a water-cooled chiller, then it's sitting in its own mechanical room, so it's very well contained. It can be very well isolated, very well ventilated, and have a sensor to make sure that we're catching if there's any leaks. As you mentioned, that changes quite a lot when we talk about a residential or a light commercial rooftop unit. In those cases, if there is a leak in the system, in some parts of the system, specifically the evaporator, you'll get a mildly flammable refrigerant leaking into the living space. And of course, then that we have a concern. If we have a flammable gas leak into a living space where you've got, your stove running, you could be smoking, you have other sparks from electrical outlets and so on. So then we have more concerns on the safety of those systems. And California has been the first state who has still mandated that even on residential and light commercial units, by January 2023, they have to be converted to a refrigerant which is below 750 GWP. That means no R410A, which is 1924 GWP, and no R134A, which is 1300 GWP. So now we're in a position where we've got to come to the market with a solution, and today nearly all the solutions we have are these A2L mildly flammable solutions, and put them on residential and rooftop units where we have risk of leaks inside the living space.
So before we get into the individual solutions for these A2Ls, let's talk about that 2023 date and why that presents a problem for the industry.
So the 2023 date that's been set by California gives a challenge because the building codes today don't allow for the use of flammable refrigerants inside the living space. So we have a conflict in that marketplace. We have California, for environmental reasons, wanting to put these A2L refrigerants in the system, but building codes have not caught up yet with the safety standards. There are safety standards out there, specifically UL 60335-2-40 and ASHRAE Standard 15, both of which have safety recommendations in place that would allow for the safe use and operation of systems with A2Ls, but those codes have not been put into place yet in California. So we've got this conflict where we don't have a solution that's non-flammable, yet we don't have building codes that will allow for the use of flammable refrigerants.
Now that we know that we're going to some of these A2Ls in residential and light commercial, let's talk about what the experience is with the rest of the world. We know you cover this market globally. What is happening in China? What's happening in Europe? And what experience can we take from that?
So maybe we start in Asia first. In China, they're still actually a bit further behind than we are here in the U.S. with the use of flammables. They're still making a conversion to R410A. But we do see places like Japan and more in Southeast Asia where small residential systems, low charge systems are using R32 today. So there is experience in those markets with these A2L mildly flammable refrigerants. Europe is following a separate path when it comes to their environmental standards. They're following what's called an their F-gas regulations, and they have some significant step downs as well when it comes to refrigerants. And so by 2020, they need to really be out of R410A. So they're a few years ahead of us here in the U.S. And what we're seeing in Europe is already transitioning to the A2Ls for the most part, R454B and R32.
And in terms of some of the safety concerns that some of the folks in the U.S. have with A2Ls, have we seen those come to fruition in Europe and Asia?
Now, of course, it's all fairly new still in the U.S. and Asia, but the safety standards have been put in place. The UL standard, this 60335-2-40, comes from an international standard, IEC-2-40, and by following those codes, we've seen safe implementation of A2Ls in Asia and in Europe.
So we do have some good experience with some of these mildly flammable refrigerants and some of these common AC applications. Let's talk about chillers real quick and where we are today and what are the refrigerant options going forward.
So within the U.S., scroll chillers, which go up to, we can say about 250 or so tons, are using R410A almost exclusively today in North America. Larger chillers, screw compressors, centrifugal compressors, oil-free centrifugal compressors are typically using 134A. As mentioned before, both of those refrigerants under the SNAP regulations are going to be disallowed.
Okay, and let's talk about kind of the difference between A2Ls and A3s, the flammable refrigerants, and what applications we can expect to see those in.
For air conditioning, having an A3 is probably going to be very, very unlikely. We know today that there's A3s used in residential refrigerators quite a lot. Europe is almost exclusively using isobutane in refrigerators. We see it in some glass door merchandisers and some other refrigeration equipment where the charge is something equal to about what you would find in a standard cigarette lighter. Very, very low charge. The residential and commercial markets for air conditioning in the U.S., we're going to need much, much larger system charges. So we're talking, several pounds of charge. So that's a very different story if we start talking propane or isobutane. So I think it'll be very unlikely that we see a lot of A3 refrigerants. We may see it in the small window units, that you can stick in the window and plug in. There could also be maybe some other innovations around using propane, but having a A3, explosive type or highly flammable refrigerant in your house is probably something that I don't think we'll see.
And that makes sense. So we've got A2Ls as a possible solution, but there is an A1 that's been officially approved that meets this 750 GWP limit.
There is. Just recently in October-November timeframe, ASHRAE gave official designation of R466A to a Honeywell blend. And so this refrigerant is officially an A1 refrigerant, so it's not flammable. It's also less toxic. The way Honeywell got the flammability reduced was by introducing a new compound to the air conditioning market, CF3I. This is a chemical that hadn't been used in any refrigerants before. It's actually primarily used as a fire suppressant. So we can imagine certainly that's not flammable. By introducing this new chemical into the refrigerant system, they get the A1 designation, but it's also brought some questions to the market, specifically around the chemical breakdown, how it's going to work in a system. Are we going to get acids formed in the system? What kind of material compatibility do we have with our typical materials that we're going to have in an air conditioning system? Because of course, having an A1 is fine, but if we do run into issues with material compatibility that causes quality problems with the system, then it's ultimately not such a good solution.
So even though this A1 is not flammable and it comes under the 750 GWP limit, there still needs to be a lot of evaluation and testing done before we can proclaim this a solution.
Yeah, it has other issues. I think that's one thing that's very clear. The reason, if we go all the way back, that we started using R22 was because it was a very good refrigerant. Its thermodynamic properties and so on. And we found other issues with it, whether there's ozone depletion, and then we move on to global warming. But in all those cases, we've been finding refrigerants that had trade-offs. So we lose ozone depletion, we pick up global warming, and so these next steps, everything is a trade-off. There is no magic bullet where we're going to find a solution that cures all our woes. So whether it's going with flammability issues or going with a different refrigerant that will have material compatibility issues is something the industry is working with now and trying to find that right solution.
Yeah, I mean, there's just a lot of moving pieces. And we talk about 750 GWP, but that's not the end game, right?
Yeah, for sure. That's the next step is to get us below 750 GWP. And in Europe, again, they're looking at that already. But the end game, we're thinking to reach ultimately the ultimate goals of the Montreal Protocol and the Kigali Agreement is a GWP level somewhere in that 300 to 350 range. And all the solutions that we're looking at today, these high pressure A2Ls, are in that, let's say, 600 to 700 range. So yeah, we'll have to make another change somewhere down the road.
Yeah, so we'll deal with that at another date. But to wrap up here, we talked a lot about California and how they're the only state at this point going with AC refrigerations. Let's just talk a little bit about what the implications are and with the timing and what we can look to see in the future.
Well, California is the only state that has set a date to have these transitions. They're trying to drive the market, right? They want to push the market to come up with solutions. As you mentioned, there's a climate alliance of 25 other states that are all also looking to make this transition. But I think those other states are being a bit more reactive and want to make sure that we have timing, that they have good solutions. So as we said, the challenge with California, because they're really driving the timing, is we're going to have to find a way that we have both an A2L solution or this A1 solution, and building codes are changed. So there's a few things that can happen. Of course, California can change their requirement. They can move the date from 2023 out beyond to 2024 or so. They can adopt building codes in the meantime. They would have to do that on their own because the national building codes won't be updated again until 2024 or after. So if California is to update the codes, they would have to do it themselves. Or we can have this A1 solution can turn out to be something that the market's okay with and they don't see very high risk and they go with a solution that way.
Wow. So as you can see, a lot of moving parts. This is a dynamic situation. And the next time we talk, things could be totally different here. So thanks, Vic, for joining us. I think this was a great conversation. And, on the next episode, we can look forward to a conversation in similar detail about refrigeration and food retail. Thanks a lot. We'll see you next time.
Great. Thanks, John.